Greetings of this session. In this session, we will concentrate on numerical on the topic mesh current analysis and node voltage analysis. So this is the third session on this topic. So let us see the problem. So in this case, for the network shown in figure below, find mesh currents. So this is the network given, and here three mesh currents are given: I1, I2 and I3. Three mesh currents. So we need to find these mesh currents using mesh current analysis. So first we will check, is there any resistance is connected in series with the current source or a resistance in parallel with the voltage source. So here this 1 ohm resistance is connected in series with the 5 amps current source, ideal current source. So this can be neglected. So this 1 ohm resistance can be neglected as it is connected in a series with the 5 ohm current source. Now to trace the path, I will name the node. This point I will take it as a this point I will take it as a B, this point I will take it as C, and this point I will take it as a D. So only 4 points. With these 4 points I can represent the network. Now to apply KVL to meshes, before that we need to check, is there any ideal current source present in the branch? Yes. So here is a ideal current source is present in the branch B to D. So in this branch current flows from B to D. It is common to mesh 1 as well as mesh 2, mesh I1 as well as mesh I2. So from these two mesh currents, what is the current equation? This source current. So this 5 amps need to be expressed in terms of the mesh current. So it is small I1 minus I2 equal to 5. So this is the first equation. As the ideal current source is present in the network, one equation is obtained by equating the source current in terms of mesh currents. Now what is the next step? Whenever the ideal current source is present, you need to identify the super mesh. So what is the super mesh in this? So this is the super mesh. So super mesh is combination of two meshes where ideal current source is present in the common branch, and super mesh is a mesh obtained by joining two meshes and eliminating the common branch. So in this case, next equation is obtained by applying KVL to super mesh. What is the super mesh in terms of this? A, B, C, D, A. This is just to trace the path A to B, B to C, C to D and D to A. Now coming to the point. So here A to B in this path, in this direction, which current flows? I1 minus I3. So I1 minus I3 flows in A to B. So path direction and current directions are same. So it is minus 1 into I1 minus I3, because path direction and current directions are same. Next, B to C. What is the current flow from B to C? I2 minus I3. So I2 minus I3 flows in this direction. So path direction and the current directions are same. So once again, minus 3 into I2 minus I3. Then this 2 ohms. So only one current flows through this branch, that is the I2, and the direction of current is the same as the path direction C to D. So once again, path direction and current directions are same, so minus 2 I2. Now coming to D to A. So in this branch D to A, there is an ideal voltage source, and this voltage is rising in the path. So D to A, if we trace the path, this voltage is rising from negative potential to the positive potential. So it is a plus 10 equal to 0. So plus 10 equal to 0. So what happens? This equation, how to simplify this? All the voltage drop across the passive elements take to the other side. So while taking to the other side, what will happen? This becomes a plus. So that is I1 minus I3 plus 3 into I2 minus I3 plus 2I2 equal to 10. So if I further simplify, separating the coefficient, so what will I get? I1 plus 3I2 plus 2I2. So it is plus 5I2. This is the minus I3 minus 3I3. So that is minus 4I3 equal to 10. So this equation I will name it as 2. So since the ideal current source is present, without applying a mesh KVL to each mesh, two equations are obtained by one equation by equating the source current in terms of the mesh current and applying KVL to the super mesh. Now the third equation, apply KVL to mesh 3. That is, the third equation is obtained by applying KVL to mesh. What is that mesh? A, C, B, A. Why I am tracing this? The path I am tracing in the direction of current. So what is the current flow through this 2 ohms? It is in the path direction and the current is I3. So what is the voltage drop across this 2 ohm resistor? That is minus 2I3. Now coming to this 3 ohm resistor, it is connected between C to B. So C to B, if I trace the path, what is the current flow through 3 ohm from C to B? So it is 3 into I3 minus I2. I3 minus I2 flows in this direction. So what is the voltage drop across this while tracing a path from C to B? That is minus 3 into I3 minus I2. What is the current flow in this branch where the passive element resistance with the 1 ohm resistance? B to A. So I3 minus I1 is the current flow from B to A. So voltage drop is minus I3 minus I1 equal to 0. Since in this all the voltage drops are due to the passive elements, I will multiply with the minus sign. So I am taking the equation to the other side. Both are one and same. So what I will get? Minus I1 minus 3I2 I3 plus 3I3 plus, so plus 6I3 equal to 0. So this is the equation 3. So 3 equations, 1, 2 and 3. 3 equations, 3 unknowns. So solve this using a Cramer's rule or solve it using a calcium. So what is the answer you will get while solving using a calcium? So how to solve using a Cramer's rule? So it is writing in a matrix form as 1 minus 1 0 1 5 minus 4 and this the minus 1 minus 3 6 into I1 I2 I3 equal to, what are the right hand side values? 10 sorry 5 10 0. So solve using a Cramer's rule and tell me the answer. So by solving you will get I1 equal to 7.5 amps, I2 equal to 2.5 amps and I3 equal to 2.5 amps. So 7.5 amps I1, I2 7.5 amps, 2.5 amps and I3 2.5 amps. So like this we need to find the solution. Okay, let us say further. Find all the branch currents using node voltage analysis. So in this, find all the branch current, this I1, I2, I3, I4, I5, I6 using branch current analysis. Find this branch current using node voltage analysis. So to find out the node, use the node voltage method, I need to identify the nodes. Now before identifying the nodes, this the ideal practical voltage source is present in the network. So normally whenever practical voltage source is present, before applying a node voltage, we need to convert that into practical current source. So according to the concept, this ideal voltage source is to be, practical voltage source is to be converted to practical current source. But in this case, we should not transform, because by the transformation, you will lose the originality of this current I1. So this current I1 is the current through 2 ohm as well as this the source current. Current generated by this 110 volt source. So in this particular case, we are not supposed to transform this voltage source to current source. Okay. Now identify the nodes. So 1, 2, 3 and 4. So these are the 4 nodes in the network. So out of these 4 nodes, one node is to be assumed as a reference node. So in any one we can assume, I will assume this as a reference. The specific reason for this assumption is this point is connected to lower potential of the voltage source, as well as it is directly connected to one of the potential of the source voltage. So I am assuming this as a reference point and will not apply node KCL to this node. So these 3 nodes, I will name this as VA, VB and this node voltage VC. Now apply branch current KCL to each node. So by applying KCL to node VA. So by applying KCL to node VA, so what are things happen? So though it is this current direction, we will assume our own direction. That is, the current VA is a higher potential compared to other node potential. So current flows from this direction as well as this direction. Whenever I am considering applying a KCL to this node, as we don't know the direction, we are considering this direction. Okay, so what happens to the equation? Minus VA minus VB by 8. VA minus VB by 8 minus, because it is outgoing, VA minus VC by 16. Correct? Now, what is the current in this branch? VA minus potential at this point. So, what is the potential at this point? This is the lower potential. So, trace a path from this point to this. So, while tracing this point, this path, it is rising. So, this is point is 112 volt. So, this current leaving from VA is VA minus 110 by 2. So, this is minus VA minus 110 divided by 2 equal to 0. So, no source current is present in the network. So, multiply with minus sign. So, multiplying with the minus sign, it becomes a plus. Okay. So, before further proceeding, take a LCM. By taking a LCM, 16 is the LCM of this. So, 2 into VA minus VB plus VA minus VC plus 8 into VA minus 110 equal to 0. So, what is the equation? 2VA plus VA plus 8VA. So, total 11VA minus 2VB minus VC. So, this is minus 880 taking to the other side. So, equal to 880. So, this is the equation 1. Okay. So, this by applying KCL to node VA. So, next is apply KCL to node VB. So, by applying KCL to node VB, so what happens to the equation? So, these three elements are connected to this. So, VB with respect to this, I will assume the current direction are as this one, outgoing current. So, what is the outgoing current equation? VB minus VA by 8. As it is the outgoing current minus. So, the expression, current expression is minus VB minus VA by 8 minus VB by 3 minus VB minus VC by 24 equal to 0. Current source is not present in the connected to this node VB. So, this is the all are current through the passive elements. So, I will multiply with the minus sign. So everything become a plus. So LCM of these three, 8, 3 and 24 is 24. I'll take the LCM as well as cross multiply. So what I will get? 3 into VB minus VA plus 8 VB plus VB minus VC equal to 0. So what will happen? Minus 3 VA minus 3 VA plus 3 VB, 8 VB plus VB. So plus 12 VB minus VC equal to 0. This is the equation 2. So this is of the equation 2 is by applying KCL to node VB. Similarly, applying KCL to node VC. So what is the equation? I will write directly. Now you need to understand why I have written this. So minus VC minus VB by 24 minus VC minus VA by 16 minus VC minus 110 divided by 2 equal to 0. So here the question arises, VC minus 110. Why this is minus 110? Because the current flow in this 2 ohm resistor from VC is VC minus potential at this point. So to find out the potential at this point, we need to trace a path from a reference to this point. While tracing a path from this reference to this point, in this path there is a source voltage but which is falling. So 0 minus 110 is this potential. So this is minus 110 volt. So now VC minus 110 divided by 2 is the current flow through this. So if I simplify this, what will happen? All are the current through passive elements. So I can multiply with the minus sign. So all become a plus. So take a common denominator of 2, 16 and 24. Common denominator is 48. So it is 2 into VC minus VB plus 3 into VC minus VA plus 24 into VC plus 110 equal to 0. So what will happen? Minus 3 VA. So minus 3 VA and minus 2 VB plus 2 VC plus 3 VC plus 24 plus 29 VC equal to this 24 into 110 when it goes to the other side. So it becomes minus 2640 volt minus 3V1 VA minus 2VB plus 29VC equal to minus 2640. So this is the equation 3. Now equation 1, 2 and 3 with 3 unknowns VA, VB and VC. So if we solve for this, we will get VA, VB and VC. Okay. Now we will find VA, VB and VC. Now based on this, calculate I1, I2, I3, I4. So now I1 equal to, this the current flow direction is in this direction. So 110 minus VA by 2. So I1 is equal to 110 minus VA by 2. I2, what is I2 direction is this direction. So VB minus 0. Here I am not considering the minus sign because the current direction I2 I am interested, not the KCL. So I2 equal to VB by 3. I3 equal to VC minus 110 divided by 2. Then V4 equal to, not a V4, sorry, I4 equal to VA minus VB by 8. I5 equal to VB minus VC divided by 24. And last I6 equal to VA minus VC divided by 16. So once you get VA, VB, VC using these three equations, substitute in this and you will get the answer. So like this, the required question is find the branch current, these branch currents using node voltage analysis. So first concentrate on the node voltages, identify the nodes and find the node voltages using the normal method, and then express this branch current in terms of the node voltages and calculate the branch currents. So in the similar fashion we need to find network parameters using node voltage analysis or mesh current analysis. Thank you.